going to talk about lesson 25, and is talking about volume and surface area. Your objective today, I will demonstrate my mathematical ability to solve real-world and mathematical problems involving volume and surface areas of three-dimensional objects composed of cubes and right prisms. Let's go ahead and look at our very first problem. What we're working with is this problem right here, and it's talking about surface area and volume. It wants to find surface area and volume of this rectangular prism. I'm going to start with, to me, what would be the hardest thing first, and for me that is surface area because it involves quite a bit of work. So surface area equals 2 times the base, area of the base, plus my lateral surface area. Well, my base here is a rectangle, so I'm going to go 11 times 6.5, because that is my base. If we look at this, the base is this gray shaded area. Okay. Alright. Now I want to add my lateral surface area, which is the area of all my sides. So I have two sides that are 6.5 by 10, because I'm talking about this side right here. So I'm going to go 2 times 6.5 times 10 plus, and I have two sides that are like this, so 11 times 10. So I'm going to go 2 times 11 times 10. Okay, now when I go back through and figure this out, 11 times 6.5 is going to be 71.5. And I'm just carrying everything down. You know how I like to do one thing at a time. 6.5 times 10, all I have to do is move my decimal one spot. So I move it so it's 65 plus 2 times 11 times 10 is 110. Now I go through 2 times 71.5 is 143. 2 times 65 is 130. And 2 times 110 is 220. Now 143 plus 130 is going to be 273 plus 220, which is going to be 493. We are dealing with surface area, so it's going to be inches squared. So that is to find the surface area. Now it's also asking for the volume. Well, volume equals area of the base times the height of the prism. Well, we know from before that the area of the base is 11 times 6.5. So I have 11 times 6.5. My height is 10. Well, we already know that 11 times 6.5 is 71.5 times 10. 71.5 times 10 is going to be 715. We're dealing in volume, or we're talking about capacity, so it's going to be inches cubed. Okay? Now, keep both these answers where you can see them, because the next problem is building on what we're doing here. So let's go ahead and look at that next problem. Pet store is, they're selling fish tanks, and they're selling this fish tank that comes in this box, and it says that it's a 3-gallon tank. The box is the fish tank has the same dimensions as what we've dealt with before, okay, on the previous problem. And so we have to figure out, are they true? Is this claim true? And you need to remember that 1 gallon was going to equal 231 cubic inches. Well, we figured out from the previous problem that the volume of this fish tank is 715 cubic inches. That's how many gallons, or how many cubic inches of water this fish tank holds. Well, how are you going to figure this out? I'm going to, since I know I need to go 2 gallons and this equals 1 gallon, I'm going to simply divide that. So 231 cubic inches. So I have 715 cubic inches divided by 231 cubic inches. And when I do that, it's going to equal 3.09 cubic inches. Now, it's asking you, is this claim true? Well, if I was to round this to the nearest gallon, okay, the nearest gallon, or the nearest whole number, it would be 3 gallons. This is not cubic inches, this is gallons. Okay? So, would this claim be true? Well, looking at this, I would have to say it is going to be true, because when I round this to the nearest gallon, that is going to be 3 gallons. Now, Jay wants to cover the back, the left, and right sides of the tank with a background picture. How many square inches will need to be covered? Okay, well, let's go from the back. The back has the dimensions of 11 times 10. Okay, plus the left side is 6.5 times 10. And so is the right side is 6.5 times 10. Now we know from before 11 times 10 is 110. 6.5 times 10, you move the decimal one place, so you get 65 plus 65. Okay. Now when I add all of that together, this is 130 plus 110. This is going to be 240. So J is going to need 240 squared inches of the background picture for his fish tank. Okay? Let's look at another problem. We're still dealing with fish tanks. One is in shape of a rectangular prism. We know it's rectangular because if you look at the base here, it is a rectangle. And the other one's in the shape of a trapezoid. So it's a trapezoidal prism. Wants to know, the first question we're going to talk about here today is which one holds more water. So I'm going to find the volume of both tanks. So tank R and tank T. Let's start with tank R first. So volume equals area of the base times the height. The area of the base here is 25 times 10. My height is 15. Okay? 25 times 10 is going to be 250. 250 times 15 is going to be 3,750. Okay? Now, let's look at tank T. Tank T is a little bit more involved. It's a trapezoid. If we remember, area of a trapezoid equals base 1 plus base 2 divided by 2 times my height. Okay? So the volume formula is still the same. It's volume equals area of the base times my height of the actual prism. So we got to figure out this first. Well, I know one base is 25, so that's pretty easy. Okay? Now, if I look from here to here is 25. But the sides here extend another 6 inches on either side. So 25 plus 12 is going to be 37. Divided by 2 times the height of the trapezoid, which is this right here, that's 8. So I have 25 plus 37, which equals 62. 62 divided by 2 times 8. 62 divided by 2 is 31. 31 times 8 is 248. That's the area of the base. So 248 times the height of the prism, which is 15. So 248 times 15, it's going to be 3,720. Well, we can, now let's make sure we have it labeled correctly. It's inches cubed. And we have inches cubed over here. Now the question is asking which one holds more water. Well, tank R holds more water by 30 cubic inches. So if we were trying to figure out which one is the better buy for the most water, it would be tank R. Now, we're going to build on this, so don't lose this work. Okay, then now let's see how we're going to build on it. Okay, so now we found out which one has the most volume, which one has the most surface area. If I was going to, which tank has the most surface area? Now remember, these are open at the top. Okay, so when we are finding surface area, we got to remember that these are open at the top; they're not closed. So we just want to know what the surface area, how much glass, essentially, are we going to need. So surface area equals, it is 2 times the base, but I'm only going to take the area of the base once, plus the lateral area. And I'm only going to do that once because remember I said this is open at the top. So I have 25 times 10 plus 2 times 10 times 15 plus 2 times 15, 25 times 15. Okay, well this is 250 plus 2 times 150 plus 2 times 25 times 15 is 375. Okay, well 2 times 150 is 300. 2 times 375 is going to be 750. Now I add these together, this is going to be 550 plus 750, it's going to be 1,300 inches squared. That's for tank R. Now let's look at tank T. Same thing, the top is open. So I have surface area equals the area of the base plus the lateral surface area. Now, if we remember correctly, the area of the base, we've already figured that out. Remember, is the base 1 plus base 2 divided by 2 times the height. From our previous problem, you should already have that written down as 248 is the area of the base. Now, my lateral surface area, I have one that is 37 times 15. So 37 times 15 plus 15 times 10. And I'm going to multiply that by 2 because I have 2 of those, plus 25 times 15. Okay, well 37 times 15 is 555. This is 15 times 10 is 150 times 2 is 300. And this we know from before is 375 plus 248. 248 plus 555 is 803 plus 300 plus 375. I'm going to add those together to make it easier on us. It's going to be 675 plus 803. I add that together, I'm going to get 1478 inches squared. So this one's asking you which one has the most surface area. Well, tank T has the most surface area, so it is essentially by surface area it's the larger one. Now there's one more question I'm asking from this, so let's go ahead and look at that. Okay, so here again we're looking at the two fish tanks. Now it says water evaporates from each aquarium. After the level drops a half an inch in each aquarium, how many cubic inches are required to fill up the aquarium? Okay, so we have to go back to what we've already talked about with volume. The volume of this fish tank was 3,750 cubic inches. Now I need to find if I take off a half of an inch. So I'm going to go volume equals area of my base, which is 25 times 10, times now 14 and a half, because I reduced it by a half of an inch. So this is still 250 times 14 and a half. This is now going to equal 3,625 cubic inches. Okay. Now it wants to know how much I'm going to need to fill that up, so I'm going to go 3,750. I'm going to subtract 3,625. When I do that, I'm going to get 125 cubic inches is needed to fill tank R. Let's look at tank T. Remember our volume before was 3,720 cubic inches. I'm going to do the same thing. I'm going to find the volume is, remember it's 248 times 14 and a half, area of the base times the height. That's going to be 3,596 cubic inches. When I subtract those, 3,720 minus 3,596, it's going to be 124 cubic inches. Okay, so to fill tank T is 125 cubic inches. To fill tank R is 125 cubic inches. To fill tank T is 124 cubic inches. Let's look at your quiz question. Your quiz question: Melody is planning a raised bed for her vegetable garden. How many square feet of wood does she need to create the bed? Then she wants to add soil to it. Each bag contains 1.5 cubic feet of soil. How many bags will she need to fill her vegetable garden? Alright? If you have any questions, make sure you bring them to class.